Learn how to get ChatGPT, Claude, Gemini, Midjourney, and other large language model to give you best response by mastering prompt engineering. Friends, my name is Abhishek Shrivastava. I am a thought leader in the space of artificial intelligence, and I educate business with the help of artificial intelligence and UX design. And in this course, I'll teach you the techniques of prompt engineering to maximize the productivity with large language models. Hi everyone, welcome to this course of advanced level prompt engineering. So friends, AI prompt engineering is a new big career with a maximum salary of USD 3,35,000, which is nearly close to 2.7 crore in Indian currency, according to the report, Bloomberg report, for the people who are in this profession. And being said so, the best part is no coding background is necessarily required.
Let's dive in. In this course, we will explore the fundamentals of prompt engineering, starting with a brief overview of artificial intelligence and focusing on large language models, LLMs, such as ChatGPT. We'll also examine other models, including text-to-image models like Midjourney, and emerging technologies in text-to-speech and speech-to-text conversion. Throughout the course, we'll adopt a prompt engineering mindset and cover best practices in linguistics to enhance our understanding. Topics such as zero-shot prompting, few-shot prompting, chain of thought, AI hallucination, and vector text embedding will be discussed, deepening our comprehension of how large language models function. See you site. We'll begin with a quick introduction to ChatGPT, setting the stage for our exploration of prompt engineering. Prompt engineering has emerged as a distinct career in response to the advancements in artificial intelligence. It entails the crafting, refining, and optimizing of prompts in a systematic manner. This process aims to enhance the interaction between humans and AI systems to the highest level of efficiency. Additionally, prompt engineering involves the ongoing monitoring and adjustment of these prompts to maintain their effectiveness as AI technology evolves. Maintaining an up-to-date prompt library is a key responsibility for prompt engineers. They are also responsible for documenting and reporting their findings and are expected to act as thought leaders within the field of prompt engineering. But why do we need AI, and how did it come about? Before moving forward, let's make sure we're on the same page about what AI actually is. Artificial intelligence, AI, refers to the simulation of human intelligence by machines. I use the term simulation because at this stage, AI is not sentient, at least not yet. This means that AI cannot think for itself, despite how it might appear. Often, when we refer to AI, especially in cases like tools such as ChatGPT, we are actually referring to machine learning. Machine learning works by using large amounts of training data, which is then analyzed to identify correlations and patterns. These patterns are subsequently used to generate outcomes based on the provided training data. For example, to better understand how AI systems work through machine learning to predict future events, let's consider a different example: weather forecasting. Imagine we want to train an AI model to predict the weather. We would start by feeding the model a massive amount of historical weather data. This could include temperature, humidity, wind speed, and atmospheric pressure readings from various locations over many years. The AI system would then analyze this data to identify patterns and correlations. For instance, it might learn that a certain combination of temperature, humidity, and wind speed often leads to rain. Once the AI has been trained with this historical data, it can begin making predictions about future weather. For example, if the model detects the same combination of temperature, humidity, and wind speed that it learned was associated with rain in the past, it can predict that it will likely rain in the future. This process of analyzing patterns in data and using them to make predictions is at the core of how AI systems work. The accuracy of these predictions depends heavily on the quality and quantity of the data the model is trained on. The more comprehensive and relevant the data, the better the AI system becomes at predicting future events. Another example could be in the financial markets. An AI model could be trained on historical stock prices economic indicators, and news headlines. By recognizing patterns in how certain events, like a company's earnings report, have influenced stock prices in the past, the AI could predict how similar events might affect the market in the future. In both cases, the AI doesn't know the future. It doesn't possess any kind of foresight. Instead, it makes predictions based on patterns it has learned from historical data. The more data it processes, and the more sophisticated the algorithms used, the better it can identify subtle patterns and make accurate predictions. In summary, through machine learning, AI systems analyze past data to recognize patterns that can then be used to predict future events, whether it's the weather, stock prices, or any other domain where historical patterns can provide insights into future outcomes. This example uses weather forecasting and financial markets to illustrate how AI systems can predict future events by analyzing patterns in historical data. As general AI techniques rapidly improve, they're able to generate realistic text, images, music, and more, thanks to vast training data and the expertise of developers. However, even the creators of these AI systems sometimes struggle to control the output. This is where prompt engineering becomes essential. For instance, if you ask an AI what is 6 plus 6, it will correctly answer 12. But when learning a new language, the responses vary widely based on how the prompt is phrased, impacting the learning experience. Using ChatGPT-4, I'll demonstrate this difference. For this, you just need to imagine about a college-going student who wants to learn English language. So for this reason, he wants to query from ChatGPT model by prompting which says, "Correct my paragraph. I went to India Gate with my friends. It could have been better if it wasn't raining," with the expectation that it will be corrected by AI model grammatically and typo, and then hit on arrow key or press enter. Let the GPT model do its work, and in completion, GPT model reacted almost similar and revised sentence, which says, "Today was a great day for me. I went to India Gate with my friends. It could have been better if it hadn't been raining." So GPT model replied in a generic way with some minor correction and reframed the sentences. Can an AI model like GPT assist someone as an expert of English language through such weak prompts? The answer is no. So, what steps should we take to effectively leverage AI models for assistance? That is to provide well-structured prompt suitable for an AI model like GPT. Let's try the same thing, this time with some better prompt which says, "I want you to act like an expert of English language and teacher. I will speak to you in English, and you will reply to me in English to practice my spoken English. I want you to keep your reply in 100 words. I want you to strictly correct my grammar mistakes and typo. I want you to ask me question in your reply. Now let's start practicing. You could ask me question first. Remember, I want you to strictly correct my grammar mistakes and typo and factual errors." So now, the GPT model is acting as an English language trainer, asking me questions for practice as I instructed. For example, it asks, "What do you enjoy doing in your free time?" In this prompt, you can clearly see that I first assign a role to the GPT model, then provide instructions, followed by syntax, and finally set my expectations for what I want the GPT model to achieve upon completion. With these two prompts, you'll easily see the difference in outcomes. A weak prompt given to an AI model, like GPT, yields a generic response, while a well-crafted prompt produces better results. This highlights the importance of prompt engineering, how we, as humans, communicate with AI models through prompts, natural language processing, NLP. The more effectively we can communicate with AI models, the more we can benefit from them, including tools like ChatGPT, Claude, Gemini, and many others. Now let me show you how we can generate an image from text using an AI model like GPT through prompt engineering. Let's start with a simple prompt. Create a high-quality image of an astronaut riding a horse. Just hit the arrow key or press enter and let GPT work its magic. Let's proceed with the course. Here are some examples of how could you write a clear prompt. So for example, we have this prompt here which says, "Write code to filter out the ages from the data." And if you run it, you would have no idea in which language it will come up with. So let's see, here it is using Python, and I actually did not want to use Python here. Okay, so we have lost some tokens as well as time asking this, so in this way we might not get the right responses. This could have been so easily avoided. So let's try again, and this time, let's be more specific by writing another prompt, which say, create a JavaScript function that accepts an array of objects, extracts the values of the age property from each object, and stores these values in a new array. Additionally, provide an explanation for each part of the code. In this example, I have Clarity instructed everything I need, like the language JavaScript, also what my data actually looks like. Not only that, I am also asking AI to explain why it is doing each step, so that I can understand not just the copy past the code, without gaining any knowledge from it. So here you can see a live demonstration from GPT-4. It gives us a write code, which I have checked. And she is also giving us an example how you would use the function, which is something we did not ask, which is super useful.
This is getting much more interactive now. You'll notice that the AI is asking questions, guiding you, and providing corrections when needed. It's like you're having a conversation with the AI, learning through its suggestions as you go. This creates a completely different and engaging experience. The prompt we crafted worked really well, didn't it? We'll dive into more of these concepts shortly.
So let's start with the basics. Linguistics is the study of language. Linguistics are key to prompt engineering. Understanding the nuances of language and how it is used in different contexts is crucial for crafting effective prompt aids. Linguistics is the study of language. It includes phonetics, the study of how speech sounds are produced and perceived; phonology, the study of sound patterns and changes; morphology, the study of word structure; syntax, the study of sentence structure; semantics, the study of linguistic meaning; pragmatics, the study of how language is used in context; historical, the study of language changes; sociolinguistics, the study of the relation between language and society; computational, the study of how computers can process human language; psycholinguistics, the study of how human acquire and use language; linguistics, which explores how humans acquire and utilize language, is fundamental to the development of large language models in AI systems. Understanding linguistics aids in prompt engineering, a critical aspect of creating effective AI interactions. By utilizing universally accepted grammatical and language structures, AI systems can generate more accurate results. Given the vast amounts of data on which AI models are trained, it is imperative that these models employ standard grammar and language structures that are widely recognized. Therefore, maintaining a commitment to standardization is essential for the reliability and efficiency of AI systems in linguistic applications. Before continuing further, I would like to tell you about prompting through some examples, which you should observe carefully and remember. While writing prompt, never assume that AI understands what you are talking about when asking it anything. For example, let's give a prompt to GPT model. When is the election? It implies that you are expecting from AI model to know that which election you are talking about, and for which country you are talking about. This may result, like, could you specify which election you're asking about and its location? There are many elections happening around the world, so I'll need a bit more detail to provide the correct information. So it means you should provide some hints in your instructions while querying the AI to get the desired result without wasting time. Even this can be achieved by asking follow-up questions. So let's ask with GPT model the same question of my earlier chat, but with some better prompt. For example, when will the next general election will held in India? The next general election in India is expected to be held in 2024 to constitute the 18th Lok Sabha. The exact dates will be announced by the Election Commission of India closer to the event. Typically, general elections in India are held every 5 years. And now we can see that this time the completion is much more precise, and now AI know what exactly we are asking about. And in this way, it's not going to go guessing and waste our time and resources. Tokens. The biggest misconception when it comes to prompt engineering is that it's an easy job with no scenario to it. Many people might think like prompt engineering just about constructing or framing of sentences, such as correct my paragraph in my earlier chat. But when you start to look at prompt engineering for creative and effective prompts for a practical use case, you realizes on bunch of different factors. Here are few important things to consider when writing a good and effective prompts. If you are asking about bigger tasks to perform, it's helpful to break it down to get best results. Assigning of a role by adapting a persona. Clear instruction, specify the format. Limit the scope by providing syntax. Set the desired expectation on completion. So let's start by assigning a role by adapting a persona. With some example, when writing a prompt, it's useful to create a persona or assign a role, asking the AI to respond in some particular character or style, just like the English language teacher example we saw earlier. Imagine we want to assign a role to GPT-4 model to act like a customer support agent. If you want to create your own personal AI customer support agent and configure the GPT-4 model for your app, you can follow the steps provided in this example. Assigning a role with a persona, for example, customer support agent. 1. Define the role. Clearly state the role and its responsibilities. Example: you are a customer support agent. 2. Establish the persona. Create a detailed persona to guide behavior and tone. Example: you are friendly, patient, and knowledgeable. Your goal is to help customers resolve their issues efficiently and courteously. 3. Specify context. Provide context to ensure the persona's relevance. Example: you work for a tech company that sells smart home devices. 4. Include example scenarios. Give scenarios to illustrate expected interactions. Example: a customer contacts you about a malfunctioning smart thermostat. Prompt: you are a friendly, patient, and knowledgeable customer support agent for a tech company that sells smart home devices. A customer contacts you about a malfunctioning smart thermostat. How do you assist them? This approach helps ensure clarity and consistency in AI responses by defining roles, personas, and context. So this is a good example to understand how, with the help of AI tools, you can create your own personal AI agent chatbot by fine-tuning prompting and training it to perform specific tasks. Now let's dive into advanced level prompting. We'll explore zero-shot and few-shot prompting with examples. Advanced level prompting, zero-shot and few-shot. Zero-shot prompting example: translate the following English sentence to French. How are you? Few-shot prompting provides a few examples to guide the AI. Example: translate the following sentences to French. 1. Good morning. Bonjour. 2. Thank you. Merci. 3. How are you? Explanation: zero-shot relies on the model's pre-trained knowledge. Few-shot enhances performance by showing the model examples, helping it understand the task better. Point number 2. Clear instruction. Let's look at another example of in which a given prompt says, please tell me what this essay is about. So I'm just going to type this and paste the essay and hit the arrow key. And then GPT will do its thing. It is going to give me a summarization and tell me what is this essay about. If I want to be more specific, I just need to add in my next prompt use bullet point to explain what this essay is about, and then GPT will again start working on it with my new instruction. We can ask GPT with more precision. For example, let me give another prompt in regards to my earlier chat. This time, my prompt says, to explain what this essay is about, and making sure each point is no longer more than 10 words long. At the end, write a summary about the essay, not more than 300 words. Let's see how GPT reply now. That's great. Let's go one step ahead and give another prompt about that essay to our earlier chat. This time, our prompt says, explain what this essay is about, and make sure each point is no longer more than 10 words long. So with these examples, you can see that you can set your own clear and specific instructions, as well as break bigger tasks into parts using the few-shot prompt technique to reach the desired result. Now let us see with some more examples how LLM-based AI model like GPT-4 can predict future with some basic example. Here is my first prompt: what is my favorite type of food? GPT replied, I don't know your favorite type of food. GPT model replied, can you tell me more about what kinds of foods you enjoy? That way I can help you better. Why she is asking such open-ended question? Because she does not predict that reason behind that is she has neither been trained nor have the any data related to that query that prompt on her private knowledge base or public knowledge base. Then on that, I gave another prompt which says, my favorite type of food includes burger fries and pizza. And now she is replying, great choices. Burgers, fries, and pizza are all classic favorites. Do you have any preferred toppings or styles for your burgers and pizza? For example, do you like a particular type of cheese, sauce, or additional ingredients? Now I will ask, which restaurant should I go in Dubai this weekend? I want you to answer me, focusing on my given preferences, which includes burger, fries, and pizza. Now look at her reply. And then, GPT will do its thing. Let us try to understand prompt engineering a little more deeply. Imagine a human language machine that can chat, write stories, and even compose poetry. This is where large language model comes into picture. They are like wizard of the digital realm, who are capable of creating a human-like text. Imagine you feed a sentence to a large language model. A large language model is a smart computer program that learns from vast collection of written text. It takes in ebooks, article website, and all sorts of written resources, allowing language model to gather knowledge about how humans use language. So in this way, just like a master linguist, it becomes an expert in the art of conversation, grammar, and style. But how does it all work? Well, imagine you feed a sentence to language model. Then that language model will analysis the sentence, examine the order of words, their meaning and the way they correlate or fur together. Then language model would generate a prediction or continuation of sentence. It will weave words together one by one based on the understanding of the language, and creating a response that seems like it was crafted by human being. Imagine a conversation with large language model ChatGPT by prompting it, which says, I want you to act like my best friend. I will speak to you about my problem, and you will reply with compassion, empathy, and a question. If I am okay in a conversational manner, keep your answer short, to the point, concise, and even limiting the reply to 100 words. You can see it replied with a well-crafted answer. You will tell a joke, and it counter it with remarks. Large language models are always ready to assist and engage conversation. Now, you must thinking these language. Now you might be wondering where this language model is used. They can be found in various places, from your smartphone virtual assistants to customer service chatbots, and even a creative realm of writing. To help us find information, offer suggestion, and create content. But remember, language model poses incredible abilities. They still rely on human to create and train them. They are in fact fusion of human wisdom and power of algorithm, blending the best of both worlds. AI hallucinations. In the context of artificial intelligence, hallucinations refer to instances where AI systems, particularly those based on large language models, LLMs, generate responses that are factually incorrect or misleadingly presented as truth. Unlike the human experience of hallucinations, AI hallucinations are not the result of dreams, but rather stem from the AI misinterpreting data. In natural language processing, NLP, a hallucination occurs when an AI generates content that seems factual but lacks grounding in reality. These hallucinations can be categorized in different ways. For instance, if the AI's output contradicts or cannot be verified by the original source, it's considered an extrinsic hallucination. Conversely, if the output contradicts the given prompt, it falls under intrinsic hallucination. Depending on the context, hallucinations can also be divided into closed domain, related to specific prompts, and open domain, not related to specific prompts. Causes. There are several reasons why AI models hallucinate, including errors in encoding and decoding between text and representations, biases in training data, or overly complex model structures. Hallucinations can occur not only in text-based applications, but also in object detection, text-to-image creation, and text-to-video generation. Just for understanding, AI hallucinations are similar to how humans sometimes see figures in the clouds or faces on the moon. In the case of AI, these misinterpretations occur due to various factors, including overfitting training data, bias/inaccuracy, and high model complexity. Preventing AI hallucinations. To mitigate these issues, AI models can be fine-tuned and configured more precisely, using various method, reducing the likelihood of generating misleading or incorrect outputs. Google's Deep Dream project serves as a clear example of AI hallucination. Imagine taking a picture of a clear blue sky with just a few small clouds. If you run this image through an AI model that's trained to recognize objects in the sky, the model might start to see shapes in the clouds that aren't actually there, like seeing a dragon or a face forming from the cloud patterns. This happens because the AI is trying to find and enhance familiar patterns it has learned from other images. In reality, there are no dragons or faces in the clouds, but the AI hallucinates these shapes because it's overinterpreting the data. Instead of just identifying clouds, it starts adding details that don't exist, leading to a surreal and unexpected output. This is how AI can sometimes produce strange or unrealistic results by misinterpreting the input data. Let's consider another example. Suppose you ask an AI, who was the first Prime Minister of India? The correct answer is Jawaharlal Nehru. However, due to AI hallucination, the AI might incorrectly respond with, Indira Gandhi was the first Prime Minister of India. This error can happen because the AI might mix up the names of prominent Indian leaders, especially if it has seen Indira Gandhi mentioned frequently in other contexts related to leadership in India. The AI might wrongly associate first Prime Minister with a familiar and significant figure like Indira Gandhi, even though she wasn't the first. This is an example of how AI can produce incorrect information by misinterpreting the data it's been trained on, leading to a response that seems plausible but is factually incorrect. This misinterpretation and generation of false information is a form of AI hallucination. AI vector and text embeddings. To finish off, I'm going to leave you with slightly more complex subject. We are going to take a quick look at the topic of text embedding and vector. In computer, since particularly in the realm of machine learning or natural language processing or NLP, text embedding is a popular technique to represent textual information in a format that can be easily preceded by the algorithms. SPE, Chili Deep Learning Model. In the context of prompt engineering, LLM embedding refers to representing prompts in the form that the model can understand and process. This involves converting the text prompt into high-dimensional vector that capture its semantic information. Vector and text embeddings are fundamental techniques in natural language processing, NLP, and machine learning, ML, that transform words, sentences, or documents into numerical vectors. These vectors capture the semantic meaning and relationships of the text, enabling machines to understand and process language effectively. 1. What are embeddings? Definition: embeddings are dense vector representations of data, for example, words, in a lower dimensional space. Each dimension captures some aspect of the data's meaning. Purpose: they enable machines to process and analyze text data more efficiently by reducing the dimensionality of data while preserving its essential features. 2. Why use embeddings? Semantic similarity. Embeddings allow the measurement of similarity between words or sentences. For example, the words king and queen are closer in vector space than king and apple. Dimensionality. Reduction. Raw text data is high-dimensional, for example, one dimension per unique word. Embeddings reduce this to a manageable size, making computations more efficient. Generalization. Embeddings can generalize across similar words or contexts, improving the performance of ML models in tasks like classification, clustering, or translation. 3. Popular embedding techniques. Word 2. VEC, a model that learns word associations in large datasets by predicting the context around a word. Skipgram, or predicting a word given its context. CBOW. GLOVE, Global Vectors for Word Representation, captures the global statistical information of words by analyzing the co-occurrence matrix. BERT, bidirectional encoder representations from transformers, a deep learning model that creates context-sensitive embeddings, understanding words in context. Check out to create embedding API here from the OpenAI. So here is the URL you should visit. And to create your own text embedding, you have to create a post request to this endpoint. Okay, so that's what you can do. You can also take a code from here. So this is an example request written in Node.js, and you would have to install the OpenAI package. Take these two methods from it. In order to pass through your OpenAI API key, that I showed you how to get earlier. As a refresher, you should go here and view API keys to create your own API keys. And once you pass that through, you can use the configuration and pass it through here in order to use OpenAI. And all of it wonderfulness, including the create the embedding method, in which you pass through an object. That object has to include the model, and also it's going to include the input. So, in this case, it is the text that you want to turn into embedding. So, this is the code for doing that. And here is the response, which comes back as an object, and then you use the dot notation to get the data. Go into the array in order to get the embedding. That will give you semantic meaning of whatever text you pass through. So please have a go at playing around with these API in order to create your own text embedding, and compare them against other text embeddings in order to find similar text. And that's it. Thank you so much for watching this course of prompt engineering.
So friends, thank you for watching our channel Coming Times. My name is Abhishek Shrivastava. I am a thought leader and curator in the space of artificial intelligence. We provide AI-powered solution to develop and sell our AI-powered product and services to various government organizations, private sector, MSMEs and startup. We also provide services and support to various institutions and organizations in the space of artificial intelligence. So दोस्तों, यदि आपको चैनल पे वीडियोस अच्छी लगती हों तो चैनल को लाइक या सब्सक्राइब करने के लिए बेल आइकन को क्लिक करें। आप हमें डिस्क्रिप्शन बॉक्स में जाकर ये भी बता सकते हैं कि आपको किस तरह की और इन्फॉर्मेटिव वीडियोस देखनी है, और इस वीडियो में या अन्य किसी वीडियो में आपको कोई खास जानकारी प्राप्त करनी है तो उस पर भी आप अपने कमेंट्स चैनल डिस्क्रिप्शन बॉक्स में लिख सकते हैं। एंड जाने से पहले, आज के सेशन के एंड करने से पहले, जो मैं हमेशा से आप लोगों से कहता आया हूँ, योर वेल बीइंग is the foundation of everything you do. So keep smiling, stay happy. Until next time, अपना बहुत ख्याल रखें। शुक्रिया।